All right, so rather than go on for a to do the matched pairs data, which is the second half of 9.3. I think it's a good idea to do one more hypothesis test from beginning to end for just a one sample mean. So when we look at this particular problem, we have some data given to us. So we're going to have to do some calculations, probably should enter it into our list one, find the actual sample mean, or does it give us that? I don't think it does it? So we need to find that. We need to find our sample statistic. So you probably want to go ahead and do that. So go ahead and enter your data. I would recommend sorting it from smallest to largest. Why would you need to do that here? Hello, I'm asking you a question. Why do we need the median? What graph am I probably going to need to look at to check the conditions? The box plot, right? Because our sample size is not bigger than 30. Remember, the conditions for means are different than the conditions for proportions. So when means, if my sample size is not bigger than 30, which it's not here, I'm going to have to check the normality with the box plot being symmetric and no outliers, and the normal probability plot being pretty linear. So those are the kinds of things you want to do when you're talking about your assumptions. So let's go ahead and take a minute and just enter in the numbers, if you don't mind, into our list one. And let's look at those particular things. But you do want to sort your list, because in a box plot, it is looking for the data to be in numerical order. So we'll go ahead and enter our values. So entering it, and then we're going to sort in ascending order from smallest to largest. We're going to tell it to do list one, and it's done. All right, so once my data is there, I want to go ahead and calculate what? What am I going to calculate? One var stats, because I'm looking at two things. Sample standard deviation and sample mean. Do you agree? Okay, so we have 47.9 is our X bar. And our sample standard deviation was, which number do I use? SX, so 2.81. We good so far? Now, with means, if I am given a population standard deviation, I can use Z's, correct? I can use normal CDF, normal procedures, Z procedures, but I'm not given that here, so this is a t-test. These are the things, kind of questions you want to ask yourself when we're talking about means. So what is the parameter of interest? The parameter of interest is our mu, right? It's a parameter, it's a population mean. And so what is it in the context here, Mike? Okay, so the mean number of minutes per hour, right? That a radio station plays music. Good, thank you. All right, let's talk about the null and alternative hypotheses. Hopefully we're getting a little bit better with practice. Since I have my parameter, it is okay to just use numbers in our hypotheses, but if you want to write them in both numbers and letters, that's fine. What variable, what letter, what number, what am I writing here? Mu, thank you, it's means, right? So mu equals, and mu, okay, because the question says, every time you turn on the radio station, it feels like there's a commercial playing, so we don't think that their 50 minutes is right. So mu equals 50, we think it's less than 50. How do we feel? Okay, so far. We know to use mu, we know to use equals in our null. Okay, perfect. Let's go on to part B. Name the test we will use. What are we going to be using? One sample t-test. And the reason we have to use a t-test is because we're not given the population standard deviation. Almost always we'll use t-tests with means, correct? All right, I say almost always because it's not always, but 99.9% of the time it will be. And we have to check the conditions. So we're in our plan step at this point, correct? So what are our 3 conditions for means? The first one, we'll do the graph part at the end. So what are our other 2 conditions? Random sample. So let's look. Does it say that we have a random sample? It says randomly select. So we have a random sample, which means this is an SRS. Again, it's not an experiment, so the randomization doesn't occur that way. It is an actual collection, random sample. All right, what is the other condition? Which means what in this case?
If it's more than 10%.
What is more than 10%?
Use it 100 times the hour.
So give me the number.
12 is more than 10%.
Right. So we have 12 samples. Do you agree? So you need to use the number 12. Don't just say it is less than 10% or use some generic word. Use the number, n, okay? So we have to say that 12 is less than 10% of all hours the station plays music. Now we can say it this way. We can also say something like, we assume the station has played more than 120 hours of music. That would be the same thing, because 12 is 10% of 120, right? So that would be another way. There's 2 ways to say it, so I don't care how you say it. Now, number 3 I've left to the last one because what do we know about our sample size? So n is not greater than 30. Do you remember that formula sheet that I gave you guys last class that had like those couple pages stapled together? On that formula sheet, it says 40. So if you want to change that to 30, you can. It's a stapled formula sheet, 2 pages. It just depends on the book that you use. This formula sheet that I gave you last class was written by a college professor. And whatever book you'll see, like it's using TI 83, which is like really old, right? So, yeah, thank you, Kiana. So this one right here that I gave you guys. So it's a little outdated, but the stuff's still there. But just change your means to 30, not 40. Okay. All right. So n is not greater than 30. So what do I have to do? I've got to check the graphs to meet our normal condition. So in other words. So I'm going to say, however, I got to check 2 graphs. So on my calculator, I'm going to check what graph first. Doesn't matter which one. Which one do you want to check first? Max plot, sure. So if I go to my stat plot, I'm going to turn that baby on, and I'm going to come down, and I'm going to be looking at the first option. Our data is in L1. I'm going to make sure I don't have anything in my y equals. My plot 1's on, and I'll just zoom stat. What do you think? It's not real pretty. Would you agree? Okay. So I'd sketch it, and I'd say, I don't know. Right? So I would say, go like that. I think that was it, right? I will say there are no outliers. Would you agree with that? That's good. And then what do you think we should check also? The normal probability plot. So we'll go and change our plot now. The normal probability plot is the last option, right? We'll redo our window. It's pretty good. The only thing that's a little concerning is the very beginning. Would you agree? But it's fairly linear. Would you agree with that? So I'll just go ahead and sketch it as well. Something like that. So I'll say, based on those 2 graphs and my comments on them about no outliers and the normal probability is I'll say the normal condition is met. If you disagree and you have a concern about the symmetry of the first graph, which I understand, you still want to proceed with the test. You might just say something like proceed with caution. Okay? So I might say proceed with caution here because the graph is not very symmetric. Would you agree? But I still want you to do the test. Okay? Any questions so far? All right. Any questions about this? Because this was a concern, if you remember, on the 8.2 quiz. The confidence interval for means. A lot of you didn't proceed because the sample size wasn't bigger than 30, and you forgot to check the graphs, right? So that was an issue. So just make sure that we've learned that. We've come a long way with that, right? Okay. So next thing. So sketch this. So now we're in the do part. We've stated, we've planned, checked our conditions, we've got our hypotheses. Now we're looking at trying to do our calculations. So let's just remind ourselves real quick about the formulas for means, because they're different than proportions. Would you agree? So the ones for means, if we're trying to find the standard deviation of our sampling distribution of means, the formula is not the square root of p times 1 minus p all over n. We don't got p. That's not our parameter. What is it here? Our standard deviation divided by, yeah. Okay, so we got to find that, right? Okay, so we calculated it. I'm not sure what the sample standard deviation was. 2.81 and divided by the square root of 12. Can someone just tell me what that number is? 0.81, sweetie? Okay. Yeah? 1? Okay, thank you. Okay. So what else do we need to do? Okay, we need a graph. But before we get to the graph, got to find our t-score, right? T, our test statistic. And remember that it is, if you look at your formula sheet, your pink formula sheet, in general terms, the test statistic is in the top right. Do you agree? It's the statistic minus the parameter divided by the standard deviation of the statistic. So in notation, that's what we have. Let's put the numbers in. What was our X bar? 47.1. What's the claim? Oh, 0.9, sorry, 0.9. And the claim was 50, right? And then we just found our standard deviation. So go ahead and take a second and calculate that for me. Did someone get it? Did you get Mike? You're going to put parentheses around your numerator. It's going to divide without, you know, see what I mean? Okay. What'd you get for me, Matt? Negative 2.59. Great. Okay. So now we're going to sketch it. I have a 0, right? And then I have negative 2.59, and I'm going to shade to the left because my alternative hypothesis was less than. Do you agree? Hello. Okay, good. Thank you. So I've shaded. I've identified the location of X bar. Well, this is the normalization. Not normal. This is the standard graph. We could do the exact same one by putting 50 here, 47.9, and shade to the left as well. Either one is okay. All right, and so this is our p-value region. The likelihood that our sample happened, assuming that the mean number of minutes music's played is 50 per hour. It's not normal CDF. I think the next one is to calculate the p-value, right? Oh, the test statistic was the next step. Sorry, I jumped ahead. So the p-value is because our T procedure, normal procedures, we do need to see to use TCDF. When I go to TCDF, it has a lower bound and an upper bound using our T's. So it's negative E99 to negative 2 point, what was the number? 2.59. What just happened? 2.59. I'm going to ask you a question about degree of freedom. 11, because it's 1 less than the sample size. And so what is our p-value? Small? Yeah. So now we have to do our conclusion. It's 3 steps. Right? 3-step conclusion. So, what am I comparing it to? Our alpha, which we didn't really say. Did it say it somewhere? I'm not sure if it did. It's less than that. So I have to say the words either reject or fail to reject. What am I going to do here? Reject that sucker. See ya, radio station that plays too many darn commercials. You're a liar, right? So we have evidence to suggest that we didn't prove anything, but we have evidence to suggest that what? The true mean number of minutes that a radio station, or that this radio station plays music is less than 50 minutes per hour. Yeah? All right. So your job, since I'm not going to assign additional homework from 9.2, is to do the confidence interval in this case and to finish quiz corrections. Okay? So we'll do our our difference of means, which is the back of this sheet. So we'll do that. We'll look at a difference of it's called paired data. We'll talk about that next class. You will not have your 9.3 quiz next class, but it will be the quiz after the class after that. Don't forget about Monday, by the way. It is touch base.